Hello guys, welcome to my YouTube channel. In today's video, I will show you how to post data using MQTT on ESP32. So before get started the video, uh, if you haven't watched my previous video, I recommend you to watch uh, the previous series of ESP32 to get uh, a good knowledge on how to get started programming ESP32 on ESP-IDF. So let's go to the topic today. So what is MQTT? So MQTT stands for Message Queue Telemetry Transport Protocol. So this protocol is widely used in IoT industry, and I think now the most uh, popular protocol that is used in IoT and other application to transmit the data over the cloud. So why we choose MQTT? So basically there are other ways like HTTP, CoAP protocol to transfer data, but MQTT is very special because of it. It is very lightweight protocol and it is very reliable and very suit for applications such as IoT. So, uh, so in IoT system, so basic the fundamental of IoT system is it has a client and a server. So the client is a device that is has sensor data or any information, and the client uh, sends the data or messages to server or another client through MQTT broker. So MQTT broker is a software that handles all the messages and the communication uh, between the clients. So the broker is very important, playing very important role in the MQTT protocol. So if you go to MQTT org website, if you want to know more, get more understanding about protocol and the use cases, I highly recommend you to visit this website, and you can find so many related documents there. And also I wanted to highlight there are few versions of MQTT protocol. So the now the I am showing you MQTT 3.1.1 how it works, because uh, uh, sorry, 3.1 how it works. So because that is the one the library that uh, the ESP-IDF library is using MQTT 3.1. But if you want to more need to learn more details about uh, the versions, these documentations has all the information. So uh, so when it comes to MQTT brokers, so uh, it's a piece of software that running on a server, So there are free MQTT brokers we can use for testing, but if you are willing to implement into a system, you have to uh, uh, install the MQTT broker in your server and do the implementation. So, but for starting point, I recommend you to use the most famous MQTT broker, Mosquito MQTT broker, because it is vastly used in the industry, and for testing purpose they have given a cloud hosted link as well, so we can use this free cloud Mosquito broker to test MQTT for our testing purposes. So, and also there are other uh, free brokers. So depending on your wish, you can choose whatever you want. So anyway, so I highly recommend to test with Mosquito org, because there is a very well document web uh, website, so you can follow these instruction and do testing. Uh, so when it comes to connection, there are several ways of connecting to or transmit data to the uh, uh, broker. So as you can see, uh, it has TCP, TLS, and WebSocket. So depending on your requirement and the way you want to authenticate the packet, you can follow this instruction and do the testing. So okay. So and also there's a, if you want to like go in deep how MQTT works and how it the packet structure and all of that. So uh, if in this website there's a link to go through this. So this is the official document. So you can read this document and try to understand how they have implemented the protocol. So uh, so as I told you before, so uh, the key components of MQTT is it should have a broker, and also it should have a sub client, which is it can be a publisher or a subscriber. So the publisher will be the device that sends data, and subscriber is the devices or the client who is listening to that topic. So and the other important aspect of MQTT is the topic. So topic uh, uh, is basically a hierarchy or a similar to URI that which we send data or publish data onto the broker. So it can be like this format, so which is very similar to URI, and depending on our requirement, we can define any topic in many ways. And also, it has a, authentication level or QoS level or quality of service level. So it has three main levels, so which is QoS 0, 1, and 2 respectively. So QoS 0 means at most 1. So that means if we publish a data with QoS 1 setting, sorry, QoS 0 setting, so uh, the client or the server, uh, we cannot assure that data will be received in the server. Like the server, this protocol is not assuring that data will be at server in case of network failure. So QoS 0 is suitable for non-critical data, so which is loss is acceptable. So and the next level is QoS 1, which is it ensure the message delivery uh, and it can be at least once data. So that means there can in the server there can be the same packet twice, more than one time if you put QoS 1. So that is because of the retransmission mechanism which has in MQTT protocol. So if you read more detail on the protocol, you will understand what is happening at QoS 1. So if you select QoS 2, that means exactly 1. So that means this protocol will assure that the that particular packet is only at or on at one occurrence in the server side. So basically, depending on your requirement, you can select whatever the levels you want. So it is very important to understand this concept before implementing a MQTT application. So as I said, MQTT is very low weight and lightweight protocol, and it is because of that uh, uh, it is used vastly in IoT products. So uh, and it has a setting called retain message, last will message. So I recommend, I am not going in detail on those because it will take some time, but you can always search on Google related, and you can find documentation related information related to this. And so okay, so that is a very brief description about the MQTT protocol. So I hope you get an simple idea on how it works. So if you move on to the specific documentation, so you can see what application that we can implement on ESP32 and in the documentation, in this documentation they have described it in detail. So I recommend you to go through this and try to understand what's happening in the program before starting it. So so while you are doing the sample project, you can always go through this documentation and try to understand it. So then it is helpful you to implement a very great product. So so as you can see, they have given few examples. So depending on the protocol application or the network level you wish to use. So today I'm showing you how the TCP example works, and it has SSL enable and QTTS. WebSocket and MQTT file. So I recommend you to test all these samples and get a good idea. Okay, let's move on to the sample. Uh, Before that, before showing you the example, you need to download this MQTT Explorer software. So if you search just MQTT Explorer, you can find it on Google, and this is basically a client software that we can use for testing, and this is very useful to implement MQTT and for our testing. And thanks to this guy, uh, I this is very good MQTT client, and it is free. So there are paid client as well, but this is enough for our testing and the implementation purposes. So first download this software from this website, and I have already done it. And so let's move on to the example. So I have load the example to minimize the time of the video, but you can find it this example on this directory. So you go to Explorer and go to show example and select the IDF version, and on the uh, let's see under the protocol. So you can see here MQTT, and we are referring this TCP example today. So these are the other example that mentioned in the ESP specific website. So if you want to go through it, so just select it and uh, follow the sample code. So this is the example code, and just create the file giving the file directory. So I have done it before, so I am not going to do that again. So in this example, it is really basic, but this is a good starting point for you to understand how this MQTT works on ESP32. Uh, so if I go through the example, so first it is initializing the dash and NVS, all of these things. So and uh, for connecting to Wi-Fi, it is using the example library, but when you are implementing a real application, you can't use this library. You have to use the Wi-Fi functions, which I described in my previous video, AP mode. So I highly recommend you to go through video, and you have to combine that Wi-Fi AP function to instead of this library. If you are making a product from so anyway, for this example purpose, we'll follow this use this provided library, and before do anything, so we'll have to go to the configuration editor and go to example configuration and change the Wi-Fi SSID and password. So I did already to my router's credentials. I did change it, but and in this example, the MQTT broker, they use the Eclipse project IO. So it is also very it is also a free broker. uh, since it is already there, I am not going to change it. So just I I think if you search on this on Google, there's yeah, there's a link. So this is very basic broker, and you can see here. So what are the ports and what you can do here. So anyway, so going back to the example. So this is the example broker, and I have updated the SID credential and save it. And so then you build the project. So I have already done it. So I have explained you how to build and those things in my previous video. So if you don't know it, just watch those videos. So basically, so if I go to the if I explain you the code, so in this section it connects to the Wi-Fi and start uh, the MQTT functionality. So this is a very important structure. So in this example, it is only configuring the broker configuration, but uh, in a product level, you have to change this configuration according to your broker or uh, other settings. So I will show you what are the settings it has, the flexibility they have given us to change. So if you go to this structure, just click, press your control button and press the left mouse key, and it will direct to library structure file. So here you can see the variables that we can change. So the username, client ID. So these are very important when it comes to implementing a system. So please read through those things and try to understand. So if you are going to for authentication level, so you have to add the username, password, certificate, and so on. So you can set up the what do you call the field message and network settings. So all of that you can configure from this structure. But for this example, they just uh, add the broker information only. So anyway, so uh, I highly recommend you to go through this library header and understand what we can do and what are the what how flexible is this library. So that is and also so this is the initializing an API, and it is registering event handler for MQTT event. So this is the handler function, and when the each event happen, this switch cases will execute. So in for this example purpose, they have just included while MQTT connected, it is publishing and subscribing to these APIs, but for implementing in a real product, you have to uh, use this API in different function and do anything uh, as you wish. But for this example, so I have just changed the topic. So if you you can see here the APIs, what are the inputs of this API, the client instance and topic as a string, and the payload, the data packet, other MQTT settings. So we can set up here, and it is already set in this example. And this is the publish API, and this is the subscribe API. So subscribe means when we subscribe into this topic, if another client is update a data packet for this specific topic, so it will receive to the device side. So I will show you how it works as well. So that is it for this program description. So let's see how it runs. So I have already uploaded into my device, and let's see how it runs. So you can see here the Wi-Fi is connected, and it just comes through this events, and you can see it has published a data packet, subscribe to it, and so on. So this each step has triggered and this function can call. So to check how it works, so basically it is successfully transferred the data packet. So this is the authentication, and if you want to check that, we can connect. If you want to check that data packets, we can connect to the same broker with the same topic credentials using this software. So that is why this client software is very useful. So once you downloaded it, you just set up this setting, so MQTT and the broker uh, detail, and this is the port since we are using TCP, and go to advanced setting, and you can put whatever the topic you want. I just put I have put Thingate here. You can put the name or anything here. Just uh, copy this topic and add it here, and so this in this code. So this is a published topic. I will delete this the previous one. This will be a public topic, so this client can connect on your 0. If you want to change it, you can do that as well. So add it, and this is the subscribe topic. You can add this as well, and can go and save it. And once you connect to it, you connect. So this client has connect to the broker. So let's see how the packet is receiving to the broker, and from the MQTT broker and to this client. So this is basically the device, and this is a client software. So let's restart the ESP and see what is happening here. So it is connecting Wi-Fi, and so you can see here, as soon as is published that packet, so that packet has receiving to the this Explorer client. So since it has subscribing into the published topic of ESP32. So you can see here in the code, it is publishing QoS1 data 3. So it has received. So in the bottom, it is publishing data at in on topic this to this topic. So it has received here. So As you can see, it is very fast and very reliable communication protocol, and is real time, and it is very great for IoT application because of this performance. So let's see how we can send data from this client to the ESP side. Uh, so there is an option called publish. So you can see here in the code, the ESP has the code it has defined to subscribe to this topic. So you put the topic here and type JSON here. So I have already done that, and just press the publish button. So you can see almost real time it has all the way go to the broker, and it has received to the ESP32 instantly. So uh, that is how the performance of MQTT works. So you can see as soon as it's connect, so without uh, without much delay, it is very instant, almost instantly received to the ESP. So you can change this value to 50, 500. So you can see it's receiving very fast. So that is why MQTT is used to control applications as well on in IoT application. So okay, that is I hope you get a basic understanding on about how MQTT works, and get an idea about how protocol works. So that is it for my today's video. I if you wish, you can subscribe to my channel. It will help me to do more videos like this, and also do uh, like as well. So thank you very much for watching this video. So I will come with other examples related to ESP32 on in future. So thank you very much.